Hello. I wanted to thank everybody for coming to our workshop today. We are the Skynet team. For those who don't know, Skynet is a decentralized cloud platform. It's kind of like a IPFS plus Filecoin situation. I would propose that we have some of the best tech in the space. I think we're way ahead of Filecoin. And the goal today is just to walk through on live demos. We have a bunch of tabs open in the web browser of applications that have been built on Skynet and just kind of show off different pieces of the API. So we have a smaller audience today, which means, and it's a workshop format, which means once you guys feel like super comfortable just asking questions, raising your hand, interrupting us, this is meant to be more of an interactive format. Before we get started with the first application, I just wanted to talk a little bit about what our goal is with Skynet, which is to decentralize the web again. And I've started to think about the cloud as more than just like iCloud or like Google Drive. I think of the cloud more as like YouTube, Instagram, Twitter. You log into an account, you have friends, you have followers, it's all this data that you've spent all this time yourself curating and managing, and it's like, it's a lot of effort and it's a lot of value to establish who your friends are, who the interesting people are to follow, to write these tweets, to make this content. And then it's all owned by Twitter, or it's owned by YouTube. They have all this data, and kind of the main strategy of corporations is to capture the data silos and control it entirely. And so if we go back to like 2010-ish, there used to be a lot of APIs. Like the big one was the Facebook API, people making games, and like there were hundreds of startups building on top of Facebook's APIs. Twitter had an API that people were building on top of, and top down, the corporations kind of realized that this is actually a competitive threat, and that it's more valuable to the corporation to lock that up and to kind of make these silos as big as possible. And so you have this thing where like Facebook can create this ecosystem that's like, oh, if you use Instagram, it's the same messenger as on Facebook. Like if you use, and if you use WhatsApp, right? They have this really integrated ecosystem, but you have to go through Facebook. You have to accept Facebook's privacy policies. You have to let them inject you with ads. And it's like, you're the one who did all the work. So that's kind of what bothers me about the centralized web on like a very deep level. And that's what Skynet's targeting. We want to get to a point where you can have a Twitter or a YouTube where all the data is owned by the users, and then these APIs that startups used to build on that don't exist anymore get locked open in a very decentralized way. Anyone can come in and see your friends list, with your permission, or anyone can come in and see like what videos have all the comments, what has the most likes, etc. And they can build applications around that without the permission of just some arbitrary central corporation whose main purpose is just extract as much value as possible. So that's kind of what we're targeting with Skynet. And rather than talk too much about like the deep technology, I think the purpose of the workshop is to get really hands-on. So I'm going to go ahead, unless anyone has any questions, I'm going to go ahead and hand it off to PJ, who's going to walk through the very basic interface. So are there any questions? No? Okay.
Great. Hi guys, my name is PJ. I work on the core team and focus on improving downloads and uploads, which by now are pretty great. And I have the honor of showcasing our Skynet web portal. So a Skynet web portal is essentially an interface to the underlying Saya network. It's open source software that we run ourselves as Skynet Labs. So on the screen you'll see sayasky.net, which is a portal that we run. But essentially everybody can spin up their own portal, making it a decentralized solution. But sayasky.net is without a doubt the largest portal out there. So this is the main interface. I'll just quickly go through uploading some files and then uploading some directories, and then show you downloads and how fast we can stream 4K media. But I hope it holds up here on the Wi-Fi. So it's a very simple drop zone interface where you can just click the plus icon. I'll start off with a simple image. So it's uploading to sky.net right now, and it immediately spit out a Sky link. So if I click on that link, it will take me to the content. So this was pretty fast. So it immediately downloaded the image. The cool thing is, if you see the URL here, it's sky.net, but if I would change this to another portal, it would be able to immediately fetch, like, actually I'll just quickly do it. So another portal is skyportal.xyz. Hope I've spelled that right.
The Sky portal is a community-run portal. So one of the community members just took the software and spun it up themselves.
Yeah. So you couldn't see it, but it like flashed for a second. It immediately loaded from the other portal. So this is just a simple image, but obviously you can download or upload any type of content. Yeah, I'll just upload a movie. It's a small movie. Like recently, we've rolled out an upgrade that allows you to upload extremely large files, like tens of gigabytes worth. I think even 100 gigabytes is possible nowadays.
Yeah, up to 100 gigabytes.
Yeah. So this is a very small video, but I didn't want to embarrass myself in front of the audience. So here it is. It immediately loaded. We also have, yeah, you can upload any type of content. So I prepared a JSON upload, and also, this is actually quite interesting. So I also prepared an index.html file. So this is just a simple index.html file, which we use internally for benchmarking our progress. So what you see here is a list of all our servers and the download times and upload times for the Skynet portal, but also stuff like the registry, which I won't get into now. But if you download, if you upload index.html files to Skynet, so essentially web apps, it essentially becomes a static website immediately. So let me just try that right now. Uploading the index.html file. And if I now visit that Skylink, it's essentially a static website. So this is a very basic example, obviously, but you can upload entire directories. So you could create a React app and then build it, upload the build directory, and you immediately have a website like a blog post or something. Maybe just show off directory upload, perhaps. So you can upload entire directories, like I said, and then we have various formats for downloading as well. So you can download them as a zip or a tar archive or anything really. Yeah, go ahead.
You said that this is the video that you did upload, and a lot of these files are really small sizes.
Mm-hmm.
Obviously, I mean, that was pretty fast no matter what. So I'm kind of questioning, like, at what point does 10 gigabytes, like you said up to 100 gigabytes, like how fast is actually, obviously, internet matters, but...
Yeah, so we're actually using a protocol called TUS to handle our large file uploads, so it's resumable. I don't have really the latest numbers of upload speeds, but I think we managed...
Yeah, I can talk to that.
Okay.
So if you're using a web browser, it's actually bottlenecked by the web browser itself. Firefox goes at like 12 to 15 megabits per second. Chrome goes at like 88 to 100 megabits per second. We haven't dived into why, because at least for this purpose, that's been fast enough. If you have your own portal and you're uploading like direct, not through the web interface, or you're using a Skapp that's more optimized, it can go up to about 800 megabits per second, up, down. So if most of the time, like sky.net, you're sharing about 19 servers that can each do a gigabit, but you're sharing that with often like several thousand other people at once. But if you have your own private portal, yeah, it's roughly a gigabit symmetric is the speeds to the network.
It's actually also, it's really quite impressive because we also, we split up uploaded data, and we erasure code it in a 1030 scheme. So essentially, the data that you have to upload is a multiple of your file size, right? So
yeah, that's wild because so I've worked with a lot of artists people who are doing like collaborative. Well, let's say they're doing like a art piece, but they're asking people from around the web to upload content to be like layered over on top of the piece. Like the biggest stuff they run into is like the like shit that they've written is trying to grab these files and like lay it over really fast and all make it like this interactive experience. And the whole thing burned down because it like came into that bottleneck of not being able to actually take content quickly and download content and allow community people to upload. So this is wild.
yeah, you should give them our number. So the upload speeds are already kind of amazing, but we've lately been focusing on downloads. And yeah, we have some improvements that aren't rolled out yet, but we're quite confident that when we have rolled those out, which should be very soon, our time to first byte on every download will be well below 200 milliseconds on. Can I say that, David? That's a little bit
the target we're
optimistic.
hitting.
Yeah, that's the target.
Yeah. So actually, do you want to go back to the grid, the numbers grid?
Mm-hmm. Here it
So
is.
we can talk about this a little bit. We have 5 columns. There are let me see if I can. So we have 3 red columns and 2 green columns, and these are endpoints that we've been trying to optimize for speed. What we are focused on is the P99 and the P999, which if you don't know what that means, so P99 basically it's like a median, but instead of taking it at the 50% mark, you take it at the 99% mark. So if we say that we have a P999 of 300 milliseconds, which I'm just pulling it from this registry read and registry write times, that means that 99.9% of all queries to that endpoint return successfully in under 300 milliseconds to the user. And so that's something that took a lot of time and a lot of engineering and just like a lot of, Chris can tell you all the traces and all the code that he's had to walk through to figure out, well, you know, when requests take 6 seconds, we just really dive in and ask, like, why did this one request take 6 seconds? And ironing out the system so that every time your request is ultra fast. And we focus on the P99 because if you're using a web page and it's a complex application and it's making 20, 30 requests before it loads, the P99 is going to generally be the thing that dictates how fast the page loads, rather than the median response time. So that's what we focus on right now. Our download times, the P99 it looks like between 3 and 5 seconds. So the median response, obviously, most of what PJ was doing earlier, we're seeing that in well under half a second, maybe under a quarter a second. But that's the median time. If we go, if he did it 100 times, one of those might take 3 to 5 seconds. So that's what we've been spending the past month optimizing. We haven't rolled out the fixes yet, but we have found an enormous amount of room for improvement, and I think that soon the download column is going to be all green as well. So that's we're very focused on making sure it's always extremely fast. I think that if you want to compete with Amazon, which is the goal, you have to perform like Amazon, and that's the standard that we hold ourselves to, and something that we're proud of. I'll turn it back to PJ.
I was actually close to being done.
Okay.
Maybe the only thing I did want to show was the bunny video. So we internally we use a video to showcase the speeds. We call it bugs, but let me just close this. But this is a 4K video of a cartoon animal, a bunny. And for example, if I seek to random spots in the file, you can see that it loads like pretty quickly. So I think like seek times are about 800 milliseconds, but this is 4K, right? So and this is not cached or anything. So if I just randomly click in the video, I have no problem streaming 4K. So we're pretty proud of that feat, right?
Yeah, let's see IPFS do that.
Yeah. I think I'm about done, right? Did I miss something?
No, I think you're good.
Right.
I think we can bring up Carol to show off the Note to Self app.
You have one. It's for COVID reasons.
All right. Hello, I'm Karol. I'm a full-stack engineer at Skynet Labs. I do a lot of server stuff and then front-end stuff. So obviously, I'm going to present one of the front-end applications that we made as a showcase. So what PJ presented are simple file uploads. And it wouldn't be complete without some dynamic part. So we added, just after the basic Skylinks, we added a registry to the Skynet protocol. And so the registry is a simple key value store that is being stored on the host alongside of the files. And with that, users can leverage what we call like a cloud database, which is basically something that allows you to make the static pages dynamic, and it opens a lot of doors.
So if you're familiar with IPNS, it's kind of the Skynet equivalent to that. You have a public key, and then you have what's called a tweak. So under the same public key, you can store any number of files with different file names or file tweaks. And the key gets signed by, by the uploader. And so when you load something from the registry, you have this cryptographic verification that the thing you're being served was authenticated or like was intended to be served by the owner of the public key. So it's a big public key-based system.
All right, so the app that I wanted to show you is a Note to Self. It's a really simple application. It's like a safe storage where you put on your passphrase, and then you can leave a message to yourself, like a secret message, whatever you really want. So I'll show you how it works. Then I will show you what's the underlying logic behind it. So let's say EthCC. So the passphrase is EthCC. And there's, so it says that there's no note for it yet. So what I can do is I can leave a note, which is like, hi, I don't know, save this note. And what it does in the background, it saves this note to the registry. And right now, if I go back or even like refresh the web page, and I go to EthCC, well, I should see the note. So there's the note. And basically, so the passphrase is, obviously EthCC is nothing secret, but you can actually share this with your friends and say like, let's say, what's the most obvious passphrase? Oh, right. So someone left a message at AAA. So how it works in the background, I will show you. It's a real simple API that we have the endpoints for. We also have the SDK, the JavaScript SDK that makes working with it very, very simple. So in the background, oh, just a sec.
Can you make it a big
Yeah, just a sec. Huh. All right, if I go to something new and submit, what you will see is a call to a registry that contains a public key and a data key, and it's 404 because there's no entry at that address. So we know that there is no node for that. If we go back, like refresh again, where's it clear? And we go to EthCC. you'll see that the registry entry was successfully found. And the registry entry looks like this. There's a bunch of data that we need to verify the registry entry. There's also a public key revision. And what it does is the data is the encoded Skylink. So it's very simple in a way that the node that we actually are sending is actually an uploaded text file. So you can see that after the registry entry has been resolved, there is a uploaded registry, uploaded Skylink with some contents that we know how to parse. So it's basically a JSON file with some kind of like basic structure, and we know how to display that. So the whole idea is that you have registry, then you upload the file, then you put the Skylink into the registry, so you have dynamic content. So if I want to update this with hello, a baguette, there was a there's a post request to the registry, and if we refresh the web page and go to EthCC again, yeah, there's hello and a baguette, which is very basic and simple in a way that it showcases the possibilities that you can do with this. So we definitely have other Skapps that are more complicated and that they build on this idea. But this is like very basic stuff that you can do with it, and with even a couple of lines of code, because this application is really like a couple of lines of code. And I will show you exactly how easy is that. So this is a React application. I'm not sure how everyone is comfortable with React, but I will just show you snippets of the code. And we're using the Skynet.js SDK that we're also developing. So at the heart of everything is the load node function, and the load node function actually gets your secret passphrase, which is what you put in your input. It generates, it derives the public key from the passphrase. So it derives the private and the public key from that, and basically fetches the JSON from the registry. We also have an abstraction layer on top of the registry, which is called SkyDB, which makes it easier to fetch and set JSON files into the registry. So you don't have to worry about all those uploading, all those encodings, the registry entries. You basically have to have a file name and your data, and some secret passphrase. So we either get an entry or we don't get an entry, which in this case it means that either the entry was found or it's not existent. And depending on that, the UI changes. And the updating is very similar. It just uses the setJSON method. You pass in the node, which this in here is just a JSON object, like a plain JavaScript object that gets translated to the JSON. And you set it, and you need to handle some timeouts, obviously in the UI, and whether someone, like if you're trying to update the registry entry that someone updated before you, you will also get like a revision mismatch, so you have to handle that. But besides that, that's the very simple API that we're exposing at at our portal, and anyone that runs the portal can expose that too. And it opens up a lot of doors for future applications.
And two things that I just wanted to call out. So the first one is just the sheer performance of, like, if you guys were watching as he's like setting the name and then loading it, all of that's happening in under 200 milliseconds. So the P99 on the registry endpoints is generally under 200 milliseconds. And if you've seen some of the IPFS demos of using IPNS or doing like decentralized identity, usually what happens is they like click login or they insert some data and then they go to a slideshow and they go through like 5 or 6 slides because it takes IPFS as much as like a minute to do these same things. And so what we've done is like super non-trivial. And so I just wanted to like explicitly call out that like this smooth, like seamless experience has a lot of engineering behind it and is really like a huge standout in the decentralized storage space. And the other thing that I wanted to call out was the 404s, since Carol demonstrated the 404. It was actually initially a difficult problem because basically you have, on the SI network today, roughly 500 nodes that participate in the registry. And so in order to say that this registry entry doesn't exist, you have to have a high level of confidence that none of the 500 nodes, including the slow ones, possess this registry entry. And so that was actually like, I think it took us like 3 or 4 weeks to, originally the timeout was anywhere from like 5 to 30 seconds on the 404, which is of course not acceptable. But it was also like a big challenge to figure out how do we take this 5 seconds down to something more reasonable. And I think right now our 404 time is typically like 800 milliseconds. Is that where we ended up?
I think it's even less than that.
Okay, yeah, so we got it even below 800 milliseconds, and I just also wanted to call that out as like, from an engineering perspective, having confidence, like confidently saying that, oh, there's nothing here in a short amount of time was a challenging problem and something that we had to spend a significant amount of engineering work pulling together. Okay, so I think Chris is going to be showing off the first, well, I guess PJ showed off the first useful app, which is file store. Oh, we have a question in the back. We'll take that. Yeah, so I don't know about Fleek specifically. A lot of the IPFS gateways use a very like heavy caching layer, which in many cases is proprietary, that pave over a lot of the performance issues. And so something we've noticed is that like if you hit a uncommon file in IPFS, it'll take 30 to 60 seconds to load, but then also you can't show that off to other people as like a baseline because as soon as you request it once, now it's in the cache. And so generally IPFS infrastructure, in my experience, is if you're once you're outside of the cache, it's incredibly slow. If you're inside the cache, most of these gateways use a very heavy caching layer to make the performance as smooth as possible. And so like most of the time when you're browsing NFTs, for example, that are stored on IPFS, those NFTs are already in the caching layer because people are viewing them all the time. It's a deep caching layer with a lot of data in it. But ultimately, that doesn't scale super well. When IPFS is a couple terabytes total, it's reasonable to have this massive caching layer. But if you scale up to internet scale, you've got millions of terabytes. No system is going to have a 1,000,000 terabyte caching layer. And so I think that's when you're using IPFS and it seems fast, it's almost always because you're talking directly to the caching layer on the server rather than using IPFS itself. Okay, Chris, do you want to?
Yep. Okay, my name is Chris. I'm also one of the core devs. I'm mostly working on the back end and recently optimizing the back end. And I'm going to show you a pretty cool application called SkyDeploy. So SkyDeploy is an application that, or a Skapp as we call them, that lets you deploy other Skapps. And as you can see here, we got a little login on the top right. which forwards us to a thing called MySky. And MySky is essentially a completely trustless and decentralized single sign-on solution built on Skynet using the technologies that you already heard about, like the host registry and all of that. Yeah, so you no longer need like sign in with Google or Facebook. You just create one account with MySky, and then you can have all your data in one place. So since I don't have a login, I create a new one, and what I get here is a seed. So it's important that you don't lose that, because in contrast to Google, for example, you cannot recover your password. So you should take good care of that. So since we need that later, I'll just put it in here for a second. Yeah, I'll sign up. And now I'm logged in. In SkyDeploy, what you can do is you essentially, you deploy your Skapp by fetching the Skylink you already got. So let's use maybe the one from the video here. Where are we? Yeah. Let's call that Big Bucks Bunny. And we put the Skylink in there. And then we add the entry. And what this does is it creates a new version of Skylink that we introduced recently, which we call the Resolver Skylink. So as you can see on the left side, this is the Skylink that we just set. And this is a new Skylink that we got. And this Skylink we can set, for example, in the TXT record of an handshake domain entry. And the cool thing about this Skylink is that it does not point to content directly, but instead it resolves through the host registry to another Skylink, and that's the Skylink we just set. So what this means is that instead of having an immutable Skylink to static content, you now have a Skylink that does not change, that's still immutable, but you can still update it, and it points to different content. So let's try the Skylink here. Okay, so as expected, the video starts playing, and let's pause this. Okay, let's try maybe a different Skylink as well. Let's use this one here. And we set the same name. We set it to a different Skylink, but without the domain, of course. So we still got the same Resolver Skylink. We got a different source Skylink, and now when we go back to this here, theoretically, when we refresh, we should end up on a different page. So yeah, and the name, essentially when we change the name, then we'll also end up with a different resolver Skylink. So this is like a unique key that when you change the key, then you also get a different resolver Skylink that you can update separately. Yeah, so should we talk a bit more about
yeah, I mean, so and just to kind of, so this app is called SkyDeploy, and the main target is deploying applications. So like if you make something like, say, a blogging platform, you don't want it to be a static, immutable application, because then if you have ideas for like upgrades or changes to make, you have to pass to all of your users, anyone who uses your blogging platform, the new immutable link every time you make an update. If you use these resolver links, instead you just give them the resolver link to the application. As you make changes to the application itself, you can change what the resolver link resolves to, and you get this much more Web 2-esque or centralized web-esque user experience on top of Skynet. And then, of course, SkyDeploy is kind of the UI for it if you want to do it by hand, or if you want to do it in an automatic way We also have a process for adding it to GitHub Actions, so that every time you push to master or make a tag or whatever hook, GitHub can automatically update your resolver link so that all of your users are seeing the new whatever it is that you're making.
Oh yeah, and another cool thing is that resolver skylinks are recursive, so you can have like a resolver skylink point to another resolver skylink. Currently, the maximum depth of that recursion is 1, but it still allows for some very specific use cases to work. Any questions?
Do you want to show this on Sky Portal?
Sky Portal is outdated. They don't support version 2 skylinks.
No.
Yeah.
This is your fault. Yeah. So one of the initial challenges of Skynet is that the portal software is fairly involved. There's something like, I think, 11 Docker containers. Yeah. So we have 11 Docker containers, a lot of things on different commits, and so the update process was fairly intense, and so a lot of the community portals are on much older versions of Skynet. That's something that we've been putting a lot of work into over the past about 3 months. We've been using Ansible, and we've been really cleaning up the process for running your own portal and also keeping it up to date. We haven't quite got to the end of the road there yet, and so the community is still generally out of date, but we want to make it so that it's like, a once a month sort of maintenance thing that takes 5-10 minutes to go through all your portals, update them, and then we'll probably do some sort of like quarterly cadence where we package everything up really nicely with some easy upgrade scripts once a quarter, and push that out to the community. So it's a gap right now, but one we're like very focused on improving, and then we want to make it so that if you're running your own portal, it's super easy to stay up to date with the network.
Yeah, so one last thing that might be interesting to show is that I just opened an incognito window in Chrome, and now when I log back in using MySky, like this, then all the links that I deployed before are still there. We could dare and try our development server. So if we try to do the same thing on .sky.xyz, which is what we use for development, but it's redeployed a lot, so I'm not sure if it's running the latest version or the right one. Then, so this is definitely a completely different physical server. Yeah, so still there. So this is similar to Note to Self. It stores the state in the SkyDB, and it just fetches the state again once you log in because it derives a key from the seed, and then it shows you that your links.
So I guess I can call out another performance thing here, which is that when we say the registry links update in 300 milliseconds, well, what we mean is that you're actually achieving global consistency on Skynet within about 300 milliseconds. And a lot of times, I think the most famous example of this would be Reddit. Even centralized databases will cheat. So when you type a comment on Reddit and you hit submit, it shows up in your browser almost immediately, and so it seems like it takes half a second to send the comment to Reddit. But actually, if you play around with like private browsing or use multiple laptops, you'll see that the consistency on Reddit takes something like, I don't know, even sometimes as slow as like 20 seconds for that comment to actually be seen by everyone else in the world. So the UI cheats and makes it look fast when on the back end it's actually not fast. And of course, the decentralized web uses these tricks all the time, but in this case, when we say 300 milliseconds, we actually mean like global consistency at that speed. And I just again wanted to highlight that because I think there are a lot of smoke and mirrors in web development, and on Skynet you don't need those smoke and mirrors, and that's something again we work really hard to make it the case.
Okay.
I also wanted to point out that the complexity that comes with those 11 containers that David mentioned is not the complexity that everyone needs to bear. So at the most raw layer, you could probably get away with just our binary, which is the SkyD, and some kind of reverse proxy, which is Nginx in our use case. And other containers are mostly for like health checks that report us on Discord some health issues, some handshake. Well, we host a full handshake node. Handshake API integration. We have also Skynet accounts, Docker container, which also is a separate service. We have debugging for the SkyD, which makes like 11 containers, but at the very raw use case, you could get away with just running SkyD plus some reverse proxy.
You probably need handshake as well.
If you want to resolve handshake domains, yeah, you definitely need handshake.
Yeah, I'm not sure if we mentioned that, but for example, if you look at this domain, sky-deploy.hns.sky.xyz, the sky-deploy is the handshake domain, and HNS is the subdomain that indicates that our portal is supposed to resolve that handshake domain. And that domain is actually resolved to a resolver Skylink, which is then resolved to a regular Skylink, which is then looked up on the network and then downloaded. So there's a lot of stuff going on in the background. It all happens very fast.
So I think that's it for the demonstrations. We have a lot of technology that we could talk about, and we're happy to dive into any aspect of the system. We could talk about handshake more. We have a whole bunch of stuff with the decentralized identity that we haven't talked about at all. So we could talk more about that, or we could answer questions related to anything that we showed. But I guess I'll turn it over to you guys to kind of steer what we talk about next.
People have been making videos and these things, but it's actually still like Foundation app is just like it's just loading videos, and it's quite shitty sometimes, especially on like my mobile phone. So do you guys have like community members that are like actively trying to create these types of hosting applications for like front end facing users?
Yeah, that's a good transition to PJ, if you want to pull up the leaderboard.
Yeah. If I remember where to find the leaderboards. Just give me a second.
It's Skynet-hackathon.hns.
I don't want to make it.
So the answer is yes. I think we have somewhere around 200 developers in our Discord who are actively making applications in one form or another. So they're in various depth levels, and we have a few who are just like way ahead. But yeah, I'll let PJ talk about the leaderboard and some of the stuff here.
Okay, so this is an application that we internally call, well, not internally, we just call it the leaderboard. We created it in the context of a hackathon we did. And what it does, like, I don't really want to dive in too much of the technical details, but we have like sort of modular components that we call DACs for data sharing between applications. And we actually, for the hackathon, we built a couple of DACs that hackers could use to build applications with. And they were all content-related DACs, but also Like we had a friend list DAC or a feed DAC, so people could build Twitter. We had a content record DAC, so people could record when new content was being created and new content was being interacted with. And the point of the story is that every application was using these DACs, which is essentially just a hosted application that communicates through an iframe with the web application. And we built a scraper for it. So we built like a data structure, a common data structure that was reused within those DACs. And then thus, because developers use the same DAC, we were able to predict where data was. So the only thing that we needed to scrape all of that user data was a DAC data domain and the user's public key. So essentially what we did was then we built a scraper that periodically just scraped the content that was stored within these DACs. And we built a leaderboard off of it. So it's, the leaderboard is very simple. It's, it keeps track of content creation and interactions. So, for example, if you build an application and, yeah, what application could you build? Perhaps an image gallery. And you have users create galleries and then people can comment on them or like them. As a developer creating that application, I would communicate with the content record DAC, and every time a user creates a gallery, I would send it a message to record that interaction or that content creation. And the same thing with interactions. And the goal of the hackathon was to build the application which had the most interaction with it, like the most users, the largest user base, and just in general the most popular application built using those DACs. So we had a couple. Yeah, I think the most successful one was SkyChess, or the most fun one was SkyChess, right? Somebody built a decentralized chess application where you could go in, log in with MySky, and then send a link to your friends, so you could have a game of chess. And we also had a content leaderboard, which is outdated now because it's been a while, but essentially what it did was it ranked the most popular content. So we would get a feel of what type of content was circulating on the network during the hackathon. And then the most fun was the user leaderboard, right? Where everybody could create an avatar. This is Monkey Dream, apparently he won. So he had, he created in total 2,914 pieces of content on the network and interacted with 1,829 pieces of content. Did I miss something? No, right?
Yeah, do you just want to step through some of the apps that people made and just kind of
Sure.
give one or two sentences about maybe the top four?
Yeah, I kind of skipped that because I don't know all of them, but I'll open up all of the
And I have
tabs.
a question on your DID stuff.
Yeah, we'll come back to that in a second.
Okay, so the Skapp one was Skynetgram, which is an application where you could upload images and then share them. But honestly, these are community-built applications, so I don't know if they're going to work well for this demo. But you see here that people uploaded applications.
Maybe don't scroll too far because it's not moderated.
Yeah, exactly. So that's also why I didn't click the links in the content leaderboard. So this is this is actually a really useful Skapp, right? It's called SkyTransfer. So you can drag and drop files and then share links with your friends. And I believe it also has a certain level of visibility, right? You can.
Yeah. So the interesting thing about SkyTransfer, it's kind of the same thing. Oh, we didn't showcase SkySend either.
Yeah, we didn't even talk about encryption.
That's okay. So the neat thing, so SkyTransfer is a similar thing to the main website that PJ originally showcased with where you can upload files. But the neat thing is that you can create like a box that you can then share with your friends, and you put files in that box, your friend puts files in your box, and both of you can see, or you can have this like group, it's almost like a Dropbox or like a group Google Drive that you share with each other. And yeah, if you're, whether it's like, it's good for team orgs, if you're sharing like log files or traces or and again, I think SkyTransfer hasn't I don't think they've updated to the 100 gigabyte file support yet. So I think it's capped at around 500 megs, but I know they have it on their to-do list to support like full 100 gigabyte files. So you can create really fun like community sharing boxes using SkyTransfer.
So when you send them the box, basically, right? Does it prompt them to then make like a MySky account, or can they just anyone who receives the link start uploading files to it?
So I think it's I don't think you need a MySky account to use a box.
I think you just need the link, right?
I think so.
Yeah.
It's super useful.
Yeah, there's a couple of like we have a lot of community members contributing Skapps, and in the beginning it was more like small proof of concepts, but over time it has grown to apps that we actually use internally. And also, just if we want to send files, like I sent David an invite to a party yesterday, or an event I had a ticket from, and we just use Skynet to share the, because we have a very easy, I think we have a Telegram integration, right? Or like on my iPhone, I have the option to upload any file to Skynet, and then the link immediately gets copy-pasted on my clipboard.
That's wildly useful, because like even like doing some of this stuff, right? We have like make videos for and get like hire designers to do shit for like EthCC things, and in reality, I keep asking to like export new things. I just want to do it myself, and so they're like, oh, I can send you the design file, but it's like a giant Adobe file, and they're always like taking forever to upload these things. And it's like, if I can, you said I could attach any file to it.
Yeah.
So if I can like put these big like rendered, non-rendered files already in a box, it's how it shows.
Definitely. We also have a thing called Skynet accounts. We haven't really spent any time discussing those, but so we limit performance on our portal, but you get a very generous free tier. But if you want to be uploading like the files you're talking about, you should probably sign up and get an account.
So basically, the free tier is 100 gigabytes, which is pretty generous. And then I think if you pay $5 a month, you get a terabyte. And this is done on a per portal basis. So if you're using our portal, that's what the prices are. If you're using a community portal, the prices might be different, either more competitive or less competitive, just depending on what the portal is offering.
So maybe as a last example of some of the apps that were built during the hackathon, this is it's called HAS. It stands for How About Skapp, and it's essentially a sort of communication tool or a collaboration tool where people in the community can come forth and put up ideas for Skapps they want to build, and then there can be some kind of discussion on it, so people can upvote, oh yeah, that's a great idea, or people can find other people to collaborate with. I think he took home the third place, but I'm not sure.
I think he ended up with the. I think How About Skapp was
the winner.
Was the winner? Yeah.
Oh.
So that was the grand prize app. It was one of the cleanest implementations. Just like the UI was like out of the way. Things were really fast. It was really clean, and so we were just for the hackathon we felt that it was like the most polished and like user friendly application. Yes, question in the back.
From what industry do the majority of your customers or clientele using your platform come from, and is there any particular industry or domain you're targeting?
Yeah. So on a consumer basis, I think pretty much everyone's using primarily the file sharing capabilities, whether it's most people are just going through the main sky.net to share files. A lot of people, so the most popular Skapp is called SkySend. The main page, Sky, is plain text files, and so it means the host can see it, anyone with the link can see it, it's not encrypted. SkySend, PJ, if you want to pull that up, is basically the same thing, except it's encrypted. And so you have a link, and then slash, and then there's a hash, which has a private key, and because there's a hash, that doesn't go to the server, so the server never sees what the private key is. So if you share these hash links with your friends, you can have confidence that no one can see what they are. At an industrial level, we have a couple of CDN customers. One of them does advertising. Some of them do, I think, like encrypted video. And yeah, I would say just in general, right now people are mostly using Skynet for its raw data capabilities. One other thing that I wanted to call out is that on the centralized web, even when you're in the centralized world, sharing large files is a huge pain. And like as Jarell was saying, if you have something that's like a 14 gigabyte like Adobe Suite file, there really aren't good options to send that around. And like even like WeTransfer really starts to like put out around 2-3 gigabytes. Yeah. And so the TUS protocol that we implemented is a very robust way to, so the main problem with large files on the centralized internet is that HTTP connections are actually not very good. And so once things get too large, there's a chance of disconnecting. They disconnect frequently, and it just becomes like a game of chance. Is like, can we make it all the way to the end of this large file before the connection gives up? And so what TUS does is it's a relatively recent protocol for web apps to talk to web servers that if the HTTP connection cuts out, we can retry. And so it's like some JavaScript on the front end and some Go code on the back end, and the application and server work together to get that file all the way through. And so that's something we've implemented on Skynet. That's how we're able to get to 100 gigabytes. And that's something that just most centralized file sharing apps don't support, and therefore they really struggle with large files. So yeah, if you have large data that you need to send around, I would actually say that Skynet, out of centralized solutions included, is probably your best option. It's just super convenient, and it can handle large data volumes nearly effortlessly.
We also don't remove the data after 7 days, or I don't know what you get on WeTransfer nowadays.
We do 90 on the free tier, and then if you pay, it'll stick around until you remove it. Yes?
It's really cool seeing the apps that have been built on it, and it seems like you could build a whole lot of stuff, obviously. Is there anything that as a team you're particularly interested to see built using Skynet or type of application?
Twitter.
There is a decentralized Twitter. If you want to pull that up, it's called Skyfeed. I'm not sure what state it is in. Oh, we pulled it up.
Yeah, I already pulled it up, but my account is probably not the best one to showcase Skyfeed. But it definitely works, but the developer developing Skyfeed is in the process of a whole refactor. So he hasn't been updating the app for the last couple of weeks, but he is planning to release like a 2.0 version soon, right?
Yeah.
But we already have a decentralized Twitter. Essentially, but my account is not the best one to show because I don't have any followers.
I think another good mention is Mars Storage, which is essentially a Dropbox clone. Works pretty much the same way. You log in, you drag and drop files there, and
I'll just quickly
stick around.
Like this is a tab I pulled up. It's also built by a community member. It's the Skynet App Store. So the URL is skapp.hns.sky.net, and it's an overview of all different Skapps that are built on Skynet with a handy search and a link to them. So it's definitely pretty cool to check out. We have a lot by now. I didn't even know we had this many. Jesus.
So 3 applications that don't exist that I would really like to exist, and I also think are kind of on the more accessible level. If you're a good UI designer, I think the APIs that you would need to work with to kind of pull the application all the way through are within reach of just any. If you can build the UI, then the back end you will be able to figure out as well. The first one is and just this for personal reasons, I would really love a music application. So an application where I can upload all my music. I have a bunch of music on my main media machine at home, and then when I travel, my iPhone has none of it, and so I'm just stuck with YouTube music, and it's low quality and I would just really like to be able to log into a Skapp that has all of my music on it, and then like hit the play button, have some playlists, and get that kind of experience. So that's something that no one's built yet that like I know I personally would use. A second thing is similar. Do that with movies and videos. And so again, my media center at home has like a personal collection of movies. I'd love to be able to watch those on the go from like a Skapp instead of, well, yeah, I just don't have my movie collection on the go. And so like, and I'm stuck with Netflix, which is not my favorite service.
So are you describing like a Plex server type thing?
Yeah, but like it doesn't even have to be as like, I would be happy if it's just as simple as like a player with a list of videos that I've uploaded and an ability to upload more, and then again maybe create playlists, and then it's Plex-esque, but it doesn't necessarily need to have all the pieces of Plex that allow it to go and pull more stuff. I don't need that as a base, and then if the base application is successful, you can start to add things like sharing features. Like if you have playlists, it would be pretty easy to kind of SkyTransfer style share playlists with other people. So you could make an extension to the app that allows sharing or like looking up lists that other people have made, or like people could use SkyFeed to post playlists that they've made. And so those are two things that I would be pretty excited about. And then the third one is we've had a couple stabs at blogging platforms, but that was before the resolver links existed. And so all of the blogging platforms that people have made so far are kind of older Skynet technology where you have to either make a handshake transaction and make a blockchain transaction every time you publish a new blog post to update the link, or you just have to pass a new link around every time you publish a blog post. And so we have like that was what they did then, because all these resolvers, like all this stuff didn't exist. SkyDB didn't exist. But now that we have SkyDB, I would love to see someone either take one of those blogs or just make a new blogging platform that uses this updating technology, so you can just pass around one link to a blog. So yeah, those are three apps that don't exist that I would be super stoked to see come into existence. And again, I don't think any of those are technically very difficult to build except for the UI. So we can talk a little bit more about distributed identity. Did you have a specific place you wanted me to start, or I can just go?
Yeah, so I don't know anything about how you guys do distributed identity. I know, so like I work at Celo, and we do a lot of distributed identity stuff with like client identity because of the text messaging to being cryptographically mapped to the blockchain addresses, and it's like very useful, but also like the way that we actually have to validate all of that is like you're essentially requiring your validators to run like this like Plumo ceremony to not validators, like essentially running this like light client ceremony to like sync up all of this shit for the mobile devices to actually like sync with the actual blockchain network itself. So I'm just interested in like new and better ways to do decentralized identity, because I'm actually on this page where yes, I work at Skynet, but I'm not sure I believe that text messaging or that cell phone numbers is the best way to be like mapping identity to blockchain addresses, and people are seeing a lot of success with like Twitter handles and email as just being easier entry points for people, specifically for like the network to keep track.
Yeah, so we haven't done anything that fancy. We just do seeds, and so you generate a seed. From the seed, there's a public key, and then you share the public key with your friends, and then you can use something called, do you know is it just Skyprofile?
I think so, yeah.
Yeah, so we have an application called Skyprofile that allows you to, do you want to pull it up? That allows you to set an avatar and a username. It might support, we'll see, it might support connecting to social media, but I'm not 100% sure that they got that far. This is a community application. But yeah, so there are kind of just loose strategies of connecting your decentralized identity to your centralized one, but the big thing is really we just make everything pub key based.
So apparently they have a lot actually. They have room for GitHub handles, Twitter handles, Facebook, Reddit, Telegrams. You can attach your email contacts. So yeah, there's a lot of metadata tagged to Skyprofiles.
And
There's a lot of builders.
yes.
Random little apps these people are all building.
Yeah, so we got a lot of like cool stuff in the ecosystem, and it's something that we're very excited about. And we like it because I think it shows how just accessible the ecosystem is. You don't have to be a genius to be able to use the Skynet APIs. So kind of related to identity, I wanted to talk about something called DACs, which were brought up a little bit earlier, but it's short for Data Access Controller, and it's a design pattern. So it's not so much like a technology that we implemented on the back end. It's a design pattern for using the registry and web sandboxing to allow data sharing between applications. So if we go back to like way at the beginning of the talk, I talked about Facebook's APIs and the Twitter APIs that used to exist. And you have this, in the decentralized world, you have this problem of data structure coordination. So if you have like a standardized profile, a challenge is that needs to be a data structure that every application has to recognize, and then if you want to extend it or make changes, or you find out that you did something suboptimally, any updates to that data structure require coordinating everyone who uses it to adapt it, and like either it has to be backwards compatible, or like there's just like this big complicated mess, coordination mess between all of your developers. And so that was something that kind of bothered us, and we spent some time and we came up with this DAC thing to solve that problem. So what a DAC is a separate application in your web browser. So it has its own URL, which means it's in its own sandbox. And so Skyprofile is an example. On the leaderboard, it loads data from Skyprofile. What the leaderboard is doing is it's opening an iframe to the Skyprofile DAC. The DAC then serves over that iframe using a technology called postmessage, a web technology. It serves an API that allows you to call functions like get avatar, update avatar, get GitHub profile, get username. I don't know what the Skyprofile API is actually, but it's something like that, which means the API that developers end up using to interact with Skyprofile is fully independent of the data structure. You don't need to understand the data structure to use Skyprofile, but it even goes a step further. Because it's a separate iframe and a separate sandbox, your application actually does not have access to the data structure, which means buggy code in some, if some junior dev makes a cool application, writes a bug, you don't have to worry about buggy code corrupting user data that's used across a whole bunch of applications. You get this nice clean API. The developer of the DAC can make sure that the API is safe and then protect the user data against buggy or malicious applications using the shared data. And so you get this really clean shared data layer that solves all of the coordination challenges traditionally associated with just open data. We hide the data structure, and it also means if the developer wants to change the data structure, add things, or like switch from JSON to a binary format or whatever, they can do that as long as they keep the API compatible. They don't even have to tell the rest of the world that they've been making changes. It's just this really clean way to share data over. The design pattern works on the centralized internet, but it primarily is used in DWeb.
Can we talk a little bit more about the Salon network? So we have a lot of nodes, I think, in Europe, because in Europe a lot of people thinking about privacy to protect our data. And yes, can we talk a little bit more how the data is stored in the network, how it's communicated to the portals?
Yeah, do you want to pull up SciStats? So that's a very big question. We've spent about 2 years working on Skynet, a year and a half, and we spent about 6 years working on the Sky network, so there's a lot more depth. But the general idea of the science, so for those who don't know, everything on Skynet is stored on the Sky network. So when you upload a file to Skynet, what's really happening is there's a portal that's translating that to SIA data, putting it on the SIA network. Then when you switch to a different portal, that portal is loading it from the SIA network. And that's what, because we use SIA for persistence, that's why you can switch from portal to portal, and it's fast and kind of invisible. It doesn't matter what portal you're using. The general premise of the SIA network is that you have a bunch of hosts who sell storage. The core, like, everything on SIA costs money. When you're uploading, it costs money. When you're downloading, it costs money. When you're storing for a week, it costs money. If you're just if you're just asking a question like, do you have a file at all, that costs money. And so we have this big, like, layer 2 that allows us to do very rapid transactions to fetch data from the network. When you upload a file, it gets split typically into 30 pieces. We use a 10 of 30 erasure coding scheme, so that means that out of your 30 pieces, any 10, doesn't matter which 10, are enough to reconstruct the file. Stated another way, you can up to 20 hosts can go offline, and you still have data availability. Then each piece goes onto a completely different host, and that gives us very high reliability. I'm actually going to make an analogy to, I think it was like 2000s era, around the year 2000, 2005. You had this concept of an enterprise hard drive. So you had consumer hard drives, which have, as we all know, like, hard drives have high failure rates. Sometimes you lose data. You had this concept of an enterprise hard drive, which is something like 100 times as expensive. This ultra expensive device that was made with super reliable components, and it just did not fail. And this is kind of analogous to how Amazon's data centers work today. You have you can have home data centers, which are really unreliable, depend on, like, local ISPs and power companies and whatever. It's tough to get above, say, 98% uptime. And then you have Amazon, which has, expert level technicians on site 24/7. They have multiple ISPs, multiple power companies. All their infrastructure is built to be ultra reliable. And so it's like 100x as expensive. In 2005, somewhere around that time, people started to realize, wait a minute, instead of spending 100x on this ultra expensive enterprise hard drive, we could just buy 3 normal consumer drives and replicate the data 3 times. And so, like, yes, we have 3 drives instead of 1, but on the net, we're saving a lot of money. It was called, like, just a bunch of disks, JBOD. And that's how all storage works. Almost all storage works at the enterprise level today. Amazon is not storing your data on enterprise drives. They're storing it in high redundancy across a bunch of cheap drives, because overall it's cheaper to store something 5 times, and it's also 3 consumer drives are more reliable as a set than 1 enterprise drive, because in order to lose data, you need all 3 consumer drives to fail at the same time. If one of them fails, you just replace it and copy the data back over. And so what we've done with the SIA network is the exact same idea. Rather than using these Amazon-grade, expert-level technicians on site all the time, ultra-expensive, ultra-high reliability data centers, we just use 30 anything data centers. And it's just people at home. We ask for about 95% uptime, which means either an hour a day or a full day a month is about how much downtime wiggle room you have, which is something that is well within reach for most home connections. And so if you go offline for like 3-4 hours, it's not a big deal. As long as it's happening, once a week or less, it's fine if you're offline. Or if you're like on vacation and your node goes offline and it's offline for 3 days and you come back and bring it back up, again, that's perfectly fine, because you're not the only one storing the data. It's on 29 other machines, and the chances that 21 of them go offline is extremely low. And so that's how the SIA network, so costs on Amazon are like $20 per terabyte per month. That's after all of their enormous economies of scale. To offer a similar, like a service with equivalent performance, we can do it at around, I think it's around $3 or $4 per terabyte per month. And again, the major cost savings, and that's without the economies of scale, and the major cost savings come from the fact that we don't need multiple ISPs. We don't need expert level technicians. We aren't asking people to stay on call or be on pager duty to keep their hosts up. It's just like if a host goes offline, whatever, bring it back next week. And so that's a little bit about the SIA network. I can certainly dive in. We brought up a map of the hosts. You can see there's a huge presence in Europe, a little bit of presence in China, some Australia presence, and then of course the East Coast where we were headquartered before COVID started. We now are a full remote team. But yeah, so we have about, I think, 500 storage hosts. These are not blockchain nodes. These are specifically storage hosts. We have a lot more blockchain nodes, but around the world storing Skynet and SIA data.
So and the data is, when I download the data, how is it, which node is used? Is it about, we have 30 nodes, there are the data, or are 30 nodes used?
Yeah.
The data?
So when you download something from Skynet, it's a two-phase download. The first phase is you ask all the nodes who has the data, then you'll figure out which 30 have the data, and then you'll do the download from generally the faster, cheaper ones. And so that's kind of what Chris, PJ, and I have been really in the hole working on over the past 2 months now, is making that two-phase algorithm as fast as possible in the 99% case. Yep. So that's another thing we're talking about is the portal model that we have. So the main idea of Skynet is to take the SIA network and make it accessible to everyday web users. And so the model that we use is a user signs up with a portal. It's kind of like using a Bitcoin exchange, so it's a custodial model. The portal takes care of your files, takes care of the SIA network, and then you can switch between portals at any time, but if you do switch between portals, you'll have to pull your files over too. And then that allows the portal to handle things like SIA coin. The portal can charge the user fiat, and so we can basically significantly expand the market. But the decentralization comes in from the user being able to use any portal they want at any time. There are two other things that we're working on. One is a way to, on the SIA network, files are custodied through something called file contracts. The portals have a bunch of file contracts, they aggregate it all together. But we could make it so that users who use a portal actually control the private keys to their own file contracts. This is a little, it's technically challenging, so we haven't rolled it out yet, but we know how to build it. And we hope to transition to a point where a user, even if you're using a portal paying entirely in fiat, you actually get the private keys to your own contracts, and you get guarantees that the portal can't delete your data or change your data without your consent. But right now portals are a custodial model. If you want to be fully non-custodial, you have to run your own, which again it's not that big of a challenge, but it's more than a standard blockchain node. Yes.
Yeah, I think that maybe sounded a bit misleading because if you want to switch a portal, you don't have to download the content and upload it to the other portal. It's just that the portal you uploaded the file to the first time, that they have to pin the file for you, right? Yeah, so it stays up. You can also do this using your own phone now. So if you just want to have full control over your files, you can just download the node and pay with Cyclones, right? Yeah.
And one of the things that we're working on with MySky is making it automatically connect you to a portal. And so once you log into Skynet with MySky, again, it doesn't work this way today, but we want to get to a point where it automatically switches you to your preferred portal. It automatically starts uploading things, or if you're not logged into the portal, it logs you into your preferred portal. And then it also has failover. So if for some reason your preferred portal is offline, it will use any number of backup portals that you've configured. It'll come with really robust defaults. And that's kind of beyond the scope of the talk today, but something we hope to be presenting by the end of the year is the key drive with this initiative is to give the users full control over their APIs. So right now, the way a user controls which portal they use is in the URL bar. You have to type it. And then there are also a whole bunch of technologies at play. You have Skynet and SkyD, and you have Handshake. And then we want to make it so that we can also support things like Ethereum or Cosmos or Celo. And so we want to be able to extend the MySky set of APIs available to a user to be whatever the user wants. Any module that the user wants to, quote unquote, install onto their system, they're able to. And it'll use whatever, it'll use Infura, or if the user configures some other service, it can use some other service, or it can point to the user's own node. That's something we hope will be ready by the end of the year, but we're still kind of specking out exactly the best way to do it. But we're very excited because we found a way to do it that should be extremely easy to pull requests into Firefox and Chrome, and then have low maintenance overhead. And so I think we feel confident that we have a politically viable way to insert the entire DWeb, the entire Web 3, including all the blockchain APIs, into mainstream Firefox and Chrome support without having to ask the Chrome devs or the Firefox devs to actually understand anything that's going on or maintain it. We have something called a bootloader that we've been working on. That's for another talk, but some really fun stuff going on internally at Skynet.
Thank you.
How many people are on your core team?
The Skynet team is 13 people.
You guys build a lot of shit for 13 people.
It has been 7 years, but I would also say that we're one of the most effective dev teams in crypto. Yeah, we write a lot.
And how big is the community?
The Discord is, I want to say, 25,000 people. The Twitter following, I think, is 150,000? 135,000 on Twitter. And then unique IPs that downloaded data from Skynet in some form in the month of June was 1.1 million. So user base is quite extensive.
We also only have 6 people on the core team, and we're looking for a browser engineer. Maybe we can plug that. We need somebody that's an expert in iframes.
Yeah, so the stuff we're doing with MySky and the bootloader I was talking about, and a lot of the API work, there's our team is good at web stuff, but we really are looking for someone who's spent a lot of time, and ideal would be, say, a Firefox OS engineer. Someone who really knows their way around iframes, around web workers, around the web security model, around the sandboxing model. This is stuff that we're all kind of sinking our teeth into, but realizing that web browsers are complicated. And so if you are, or you know a browser engineer who's really familiar with all the deep internals of web security and sandboxing and iframes and that side of the world, we would love to have an expert on our team who can help us walk through, save us 1,000 hours of reading browser documentation, maybe even more. Yeah, so I think that about wraps it up. I think we have about 20 minutes left in the session, so we can just we can walk around and be available, and you can come talk to us. So it's the 4 of us, and then in the back we have Phil, who works on a lot of the configuration and Ansible stuff I was talking about. We have Monsi, who does biz dev and marketing and really everything that's not development. And then we also have David over here, who is the community member that runs skyportal.xyz. He's made apps. I think you made Sky Gallery, yes? Yeah. So he's made apps like Sky Gallery on top of Skynet, and we'll be around happy to talk to you. So thank you very much for coming. I hope this was interesting and exciting.